today, if you didn't grab one, it is over by the door, or if I didn't hand you one because I didn't have them over by the door when you first came in, they are over there. We are going to go over area of sectors. Now, the reason we went over area of circles is because a sector is part of the area of a circle. So, just again, re-looking at our formulas for circles, circumference is 2 pi r. Okay, that's the distance around the circle. The area, okay, is equal to pi r squared. Okay, so you have to use the radius for area. So going over a little bit more with area, we want to find the missing measures. So number 1, find the radius of a circle with an area of 95 square centimeters. So you do just still use this area formula. Now we're given the area in this problem, so you would plug in 95 for A. And we're trying to solve for the radius, so we're just going to try and get the radius by itself, or r by itself. So I would divide both sides by pi. Okay, and I got about 30.24, and that's equal to r squared. Okay, then we have to take the square root of both sides. Okay, to get r is equal to about 5.5 centimeters. Okay, so if we're given the area of a circle, we can still find that radius. Okay, same thing in number 2. We are given the area of a circle is 196 pi yards squared, and we want to find the diameter this time. So still just using our area formula, we're given A is 196 pi, so we'll plug that in for A. And again, I want to solve for R. So I'm going to divide both sides by pi. Okay, they end up canceling here and canceling on the left. Okay, so you have 196 is equal to r squared. Take the square root of both sides. Okay, and r will then be equal to 14. However, in my directions, it wants us to find the diameter. So if the radius is 14, how do I find the diameter? Multiply it by 2. So I take 14 times 2. So the diameter is 28 yards. Okay, so I do want to move into what a sector is then. So sector still has to do with a circle. So think about a sector of a circle as a piece of pie. Okay, so think about it as a piece of pie. Pie is in a circular form. If you slice out one piece, okay, that would be considered a sector of that circle. Okay, think of it as just a piece of that pie. So it is a region bounded by a central angle and its intercepted arc. So you're still looking at this central angle and then the arc that's intercepted. So the equation that we're going to use, equation that we're going to use is right here. So the area is equal to x over 360 times pi r squared. Okay, Pi r squared is just the area formula for a circle. Okay? That x over 360 has to do with your central angle. Okay? So x is equal to the central angle measure. Okay? X is the central angle and r is still the radius. Okay? So the reason we have that x over 360, that's taking a fraction of your circle. It's just taking the piece of that circle and then multiplying it by the same area of that circle just to get the one piece. So I'm going to go over our first example here. This is just explaining again what each piece is. Central angle is x and a radius of r, and you're using this formula. Okay? So a circular pizza has a diameter of 12 inches and is cut into 8 congruent slices. What is the area of one slice to the nearest hundredth? Okay, so we're going to draw a picture. Okay, so we have a circular pizza. It's cut into 8 congruent slices. Okay, just how you would normally slice a pizza, a circular pizza. Okay, 8 congruent slices. Now, the diameter is 12 inches, meaning your radius is what? 6. Okay, so a radius from the center point to this outside point would be 6 inches. Now, to use our equation for the area of a sector, we need a central angle. Okay, we weren't given the central angle. However, we can figure out what one of the central angles is. So a total, this circle's total has to equal what? 360. Okay, so I can take 360 and divide it by 8 because that's how many slices I have. Okay, so one slice is going to have a 45-degree central angle. Okay, so that would be this piece here. So now I have my central angle measure, or my x value in our formula. I have the r value. Okay, that's 6. So I can now find the area of the sector. Okay, so x is 45, that's over 360, times pi, r is 6, and that's squared. Okay, and we can just plug that into our calculator then. So 45 divided by 360, I would press enter and then multiply by pi and multiply by 6 squared. Okay, so make sure you can enter that into a calculator. I figured. Okay, so the area of that sector will be 14.14 inches squared. What? All right, questions on the first one here? All right, then on the next page, okay, I want you guys to do number 4. So use that formula from the front, use what you're given in the picture, and find the area of the shaded sector. What?
Oh, God. Take that back. I will crush the salt. Or you don't. No. Yeah.
I kicked the chair.
I didn't see the top. What? Like what you were over here.
Oh, I found the diameter.
How do you do that?
Well, I took the radius and multiplied it by 2.
What formula do we use? The top one? Oh, we're here.
Mm-hmm.
Is it 4.4? Yeah, yes I did. Sierra.
All right, so number 4, your central angle or the x value in your formula is 53. Shh, quiet now. Okay, so the x value in that formula is 53 over 360 times pi. Your radius is 4, and that is squared. Okay, so you should have gotten 7.4 feet squared as your area of that sector. I'm going to do 5.
I already did 5. There you go.
Okay, so number 5, we're still finding the area of the shaded sector. Okay, so in this one, you're given a central angle measure of 65. But I don't want to plug that in as my x value because it's not the shaded sector's central angle. To find that, we need this angle right here that goes all the way around. So you do 360 minus 65 to get that angle measure. Okay, it is 295. So that's the x value that I want to use in my area formula. So I have 295 over 360 multiplied by pi. My radius is 11, and that is squared. Okay, so make sure you are looking at that shaded region or that shaded sector. You find the area of the total and then subtract the area of that sector? Yeah, that works too.
I was scared.
There's multiple ways you can do that problem. Isaiah did it the other way and he got the right answer. What time is it? Okay. Looking at number 6. Okay, so number 6 says the color wheel at the right is a tool that artists use to organize color schemes. If the diameter of the wheel is 10 inches, okay, diameter is 10 inches, shh, quiet, and each of the 12 sections is congruent, find the approximate area covered by green hues. Okay, so the green hues, I know this is in black and white.
Yeah, this is fine.
is this section that's bolded where that X is or that arrow is pointing. Okay? Okay, so there are three little sections here within the green hues. So what we need to do is find the central angle measure. Now, it said there were 12 sections. So this is like the first one we did on the front. Okay, there's 12 equal sections. So to find one of the central angle measures, we can take the total, which is 360, and divide by 12. That's 30 degrees. Now 30 degrees is the central angle of one of those 12 sections. In the green hues, there are 3. So to get the central angle of the green hues, you need to add that 3 times. Okay, so our X value would be 30 times 3, which is 90 degrees. Okay, so now I have that X value. What's my R value? What's my radius? 5, because the diameter is 10. So now I can find the area of the green hues. Our central angle is 90 over 360 times pi. Our R value is 5 squared. It is 19.63 inches squared.
Write in words, no, thank you.
Okay, questions?
Why did the other 2 questions?
Oh, relax. All right, I'm only going to do number 7. Okay, so number 7 says write in words how you would find the area of the shaded region. Okay, so think about this. What would you have to do to find the area of that shaded region? Yes, Alyssa. What?
2 pi r squared.
It's kind of close. Find the area of both and then subtract them. So find the area of the square, find the area of the circle, and then subtract the circle from the square. Okay, so I would say find the area of the square, then find the area of the circle, subtract the area of the circle from the area of the square. Okay, so that would be the plan for number 7. Okay, so writing out the plan, you'd say subtract the area of the circle from the area of the square. Make sense?
Sure does.
Perfect.